Hi guys, my name is Catherine Cushel, and in today's video I'm going to showcase to you my final project for this class. So essentially the goal for this project was to update an open source tool called PeePDF with a discrete cosine transform, also known as DCT. Essentially, PeePDF is an open source tool that is used to determine whether or not a PDF file is malicious. DCT stands for discrete cosine transform, as mentioned, and what it does is it pretty much strips away the high frequencies from images, and what this does is that it saves space and it also allows the human eye to view the image as it was intended to any which way without the high frequencies. But from an attacker's perspective, what we see happening is that sometimes the attackers actually inject malicious content into this extra space, and this content is definitely can definitely be bypassed by antivirus scans. So what I wanted to do for this project was update or enhance the PDF tool with the DCT functionality, allowing it to be able to give the user the ability to understand whether or not the images coming into a PDF file has malicious content from an image standpoint. So essentially the way DCT works, it's that it takes an image and it breaks it down into 8x8 blocks. And it does some mathematical calculations to pretty much figure out how much weight each of the cosine waves has to that image. And it removes the high frequencies from that image, and then when you're actually receiving the image, you'll need to encode it back with the cosines, and it will be able to view the image as it was intended to be seen. So that's pretty much what DCT is and what PeePDF is. And for my project here, I was using my Ubuntu machine and Python 2.7. I also wanted to note that you'll need to have CV2 installed, OpenCV, but for this tutorial I'm using CV2 and also NumPy and String.io. So today's video is just going to be a quick before and after of what the tool used to look like before and then what it looks like now. So let me jump in and show you how to run it and essentially what the outputs are. So I have the tool saved on my desktop here, and that's what we see that I'm CV'd into right now. So to run the tool, you want to be able to type, you want to run the PDF script, the PeePDF script. I'll do a -h and show you all of the usage functionalities it has, which is pretty neat, but for this tutorial we'll be using -i, which is the interactive mode. And you'll need to give it the PDF file. And in this case, I've generated a PDF file that I know has a JPEG image in it, and I've saved that on my desktop to be used for today's demo. So let's go ahead and run the tool in desktop test 1. PDF, okay. So once we hit enter, you'll see that the tool pretty much generates some really neat information about the PDF file. It tells you the name of the file, the MD5 hash, and things of that nature. And it also gives you the streams of the image, of the file, excuse me, and the objects that says there. So drilling down into the DCT portion of PeePDF, essentially what's happening right now is that the way it's written, it's reading the stream from memory, and it's using PIL and String.io to open that stream as an image. He then saves the image, so he saves the stream as a string and returns that stream to the user. As I was doing some analysis to figure out how I was going to approach this, I tried to write out some of the variables here. So where he was actually he was reading the stream as a string and opening as an image. I saved that, and I was hoping to print that out as a file, and I was expecting to see the image come back to me, or even down here where he is converting the stream to a string, was hoping to save that as a JPEG and potentially have the image kind of regenerate itself. But unfortunately it didn't, so I wasn't sure how that was going to be helpful to the user, because from an image standpoint you would need to see what the before and after image of the image looks like to be able to actually know if the content was malicious or if any changes have been made. So here I'm just double clicking on what I've outputted from the existing script, and as you can see it does not return an image. That was for the stream, excuse me, and then for I saved the variable as well, where he was actually writing it out. So again, you can see that it did not generate an image. So what I wanted to do was actually generate that image from both the encoded and decoded image, and then have the user be able to open up the images side by side to do the comparison to see if there were any changes or anything done to alter the images. So let's give that a second. So here what I have is pretty much the script that I made some updates to, and the two functions that I was focused on was DCT encode and DCT decode. And the way I thought about this is I wanted to take that stream that was coming in and then be able to convert it into an 8x8 array so DCT can actually perform or actually be able to work with that. So that's pretty much what I'm doing. I'm taking the stream, converting it into array, and then applying DCT, in this case using CV2 to actually perform the decoding and encoding to the images. So here I've created the function called opencvimage from string.io, and we're reading the stream and we're using NumPy to convert that into an array. And then I'm returning that decoded, values to be seen as well. And then in this function here, I'm actually trying to write out the image so that the user can be able to double click and open it. So here I'm reading the stream from memory using string.io and then running that function that we just looked at on the image string, and then saving it to image1, and then using that to output it into a file. And I'm calling that file test encode, and want to be able to run this binary stream here on that file and then hopefully generate that encoded image. So again, doing some more of that here, and then I'm also saving the image as well so the user can actually be able to go into the temp folder and open it. And then for encoded, kind of follow the same logic where you take the stream and convert it to an array and then perform DCT. But as I was doing some research on DCT, from an encoding perspective, you're going to need to be able to reshape or resize the image a little bit. Just because when it needs to be encoded, it comes back ginormous and it doesn't open. So what I was trying to do here was actually scale it down by half. But unfortunately, the encoded image does not work. It doesn't open, but the good thing is that it's able to detect it as a JPEG. And you see here, I'm actually writing it out to a file here, which I'll show you a bit later. But for some reason, I'm almost positive it's a sizing constraint, but the JPEG doesn't actually open. So let me jump over to a terminal, and I'll run this and I'll show you exactly what happens. So here I have my my terminal here that's pointed to my downloads, and this points to the PeePDF master, which we just looked at over here. So let me go ahead and I'm going to run the same test file in the interactive mode so we can actually take a look at that. Test 1. And just running it generically, and you can really see that it comes back again with some of the similar content that we saw before. And then to actually run the encoded part of this, what you want to do is you want to type in filters, because DCT is definitely one of the filters that this tool wants to be able to provide for. And here you can see a listing of some of the filters that needs to be built or that has been built so far. And then jumping back to the code, as mentioned, we want to be able to take that test encode file that we generated from our DCT image and actually encode that. So essentially that's what I'm trying to do. I'm trying to take this file here and use it in our encoding methodology here. So to do that, we have filters, and then to run DCT on it, we want to be able to type in encode. And I'll show you. Actually, if you type in encode just the way it is, you can actually see the 3 different usage items that you can actually pick from. And then for today's demo, I'll show you it on a file, because I'll show you it on the test encode file. So what we want to do is type in encode, and we're going to give it the file, and that file was named test encode, and then the filter type is going to be DCT. And for the purpose of this demo, I actually printed out the array for you guys to see, which can be seen right here. And then let's go into my downloads and I'll show you the image that opens and the image that doesn't open. So let's give it a second to load. But in my downloads folder, if you go into the PDF master folder, you scroll all the way down. Here, the encoded file right here. And I actually, when I was doing some tests on this, I actually tried to write it as a JPEG and then write it without a JPEG to see if it would add a file in it. Unfortunately, it just didn't open. I'm suspecting it's probably a size constraint, but it can definitely be a future enhancement to this tool. So that doesn't open, but here, let me jump and show you in my temp folder what the decoded image looks like. And you'll see here. Here's our decoded image, and you can see it comes back as a compressed version of what we actually gave it. And then if I open the actual PDF file that I gave it, which was test 1, we're going to see that the image is almost identical. It's just a decompressed version. Give my machine a second to catch up. But here we go. Here's our image, and then here's what the decoded version of that returned. So, very, very close match. Yeah. So that pretty much sums up my project. Unfortunately, the encoded portion of this did not open, but I'm definitely going to leave that as a feature enhancement for this tool. And I'm also using a PDF file with one image. It would be great to see it done with a PDF file with multiple images and some text in there. But ideally the logic it's pretty much built out, and just a couple minor enhancements has to be made to actually see this through. I hope you guys enjoyed this video and learned something about DCT and give that PeePDF tool a try because it's pretty cool. Thanks so much for watching. Bye.